Hey everyone. My name is Gil, and I'm a software developer and also a team lead at Wix. I work at Wix over 4 years, and I'm a part of the team that works on the core renderer. So actually, the Wix renderer is the application that renders Wix websites. And in the last 2 years, we've been working very hard to rewrite this application with the goal of writing the fastest site renderer in the world. So how do we measure ourselves? This is the core web vitals report. This report actually is publicly available, and it's based on data that actually Google gathered from websites all over the world, actually all the websites, and they actually measure key performance metrics. I'm not going to go too much into details here, but you can find a lot of information on this in the internet. But I can just say that Google is using this data to rank sites SEO. So you can probably imagine how important that is for us. Also, obviously, performance is very important for our users, and the experience of our users is obviously much better when our sites are fast. They are buying more, they're staying more, they're coming back to the sites more. But the core web vitals give us a tool to measure ourselves and know how we are doing versus other competitors. So as you can see, since around July 2020, when this is around the time that we released the first version of our new application, we got much better. And today in this talk, I want to tell you the core and the most fundamentals design changes that we did in our new application. I want to tell you the issues that we had with our old application that got us, like you see, a very low core web vital scores. I want to explain the issues, and I want to tell you how we fix them in our new web application, in a new Wix renderer. So I thought a lot about how to display or how to present those ideas, and I think the best way is to just show code. I'm not going to do live coding; it takes too much time, but I do want to show you code examples of issues and code examples of how we fix them. And so I wrote this very simple application that I want to go over. This simple application is a very basic site renderer. And this way, I'll also show you the issues that we had and also how we fixed them. So I'm going to go over to the code. And first of all, before we go to the code, I want to show you a little bit about Wix. This is the Wix editor, and Wix, I'm sure most of you know, is a platform to build websites. So this is the Wix editor, at least one of them. We have multiple Wix editors. And I just have here a very simple website. You can see a button, image, and a text. I added all of them from the add panel. I can drag them around, and whenever I hit publish, I get the URL of my website. I can go to my website, and this is the website that I just created using the Wix editor. And the way that it works is when I click publish, everything that I edited and changed in my editor is actually saved in a big structure. The structure of the site is a big object that our application gets as an input, and this is how we know what to render. So I want to show you the application that I wrote here. It's a very simple application. It has a very simple structure. Let's look at this structure. So I have here the list of components. I have here an array of 3 components. One is the button, the image, and the text. Each one has the comp ID, the type of the component, the data. A button has a label and a link. I'll talk about it in a second. Image has a source, and a text has just the text. So let's go over quickly on the application that I wrote here. This application, first of all, it fetches the site structure. It has the array of components, and then I'm using React, and I'm rendering those components to the browser. So let's see what I did here, first of all, I have my 3 components: button, which is just a button, image, obviously an image and a text. And then I have the mapping between the types of my components in the structure and the actual React components that I'm going to render. This is the viewer components object. And then I have my renderer component, which simply loops all the components, gets the right React component from this map, and basically just renders it. And it passes each component structure to the React component in the props. So button gets the data, the label from the data, image gets the source, and the text gets the text. So this is how we end up with an application that this is what it renders. Very simple, but I'm going to use this in order to present also the issues that we had and also how we fixed them. So if you don't have any questions about this simple, actually, I'll go over it very quickly again. Again, we have we fetch the component, we render using this React renderer. Looping the components, I have here 3 types of components, and basically I'm just rendering each one of them and passing the structure object to each one of them in the props. So what I want to do now is I want to start to show you a simple example of a small feature of the button, of the link button. This is a small feature that we have. It's probably the most basic feature that we have in Wix. In this feature, you can see that the user basically can add an action to whenever the button, the user clicks the button. So in this case, it's a link button. So let's see the options here. So I clicked this link menu, and now I have the option to choose what the link does. So I have either does nothing, either go to a web address. I can choose the web address. I can go to a specific page. So if I added another page, I can choose to go to this other page here. I have this anchor, which is just another place in the page. I can go to the top of the button, email, phone address, open a lightbox. I can do a lot of things using this button. So if I publish, let's say I created this. So if when I click the button, it would simply go to when I click the button, it will simply go to this other page I created, which is in this case an empty page. So let's go back to the code and let's try to implement this small feature in our simple renderer. So first of all, I'll start with the site structure. I have here this link object that was created because I created this link because I chose that I want a link in the button, and also I chose that I want to type page because I want to go to a different page, and also I had to declare which page I want to go to. In this case, I have an ID of the other page, and together in the site structure next to the components, I have the list of pages, which is mapping between a page ID and a path, right? So page 1 is home, and in my case, page 2 is the about page. And I saved the path in a different structure, not here, because I want to give the user the ability to change the path without me going to change all the reference inside the components. So I just save a page ID, and then I have the mapping between the page ID and the path in a different structure that I can change whenever the user changes the path. So this is how I saved it. And now let's look at the render at the button. By the way, a small disclaimer before I start displaying the issue here is that it might seem like it's very specific to our use case, but I promise you that when I finish telling you about it, I'll tell you why I think it's actually not very specific to Wix, and you can find this issue in any other web application, but I'll get to it in a second. So let's see how I implement this small feature in my small application. So this is the new button component. It now has a link in the data. And if I do have a link in the data, I need to first of all resolve the link because I want to render an href. I actually want to render an anchor if I have an href, because it's probably better for SEO. If I don't have a link, then I want to render a simple button, which basically does nothing in my case. So let's look at this resolve link function. It gets the external base URL because I need to concat it to the href. I have the entire pages that we saw before, and I also have the link object. Let's look at the resolve link logic. So like you see here, I have all my options of different types in my resolve link function. If it's a page, I want to concat the external base URL to the path that we saw before in the structure. If it's an external link, I probably have the external link in my link object. And maybe if it's a pop-up, I don't even have an href, maybe I have something else. And you probably can imagine this code can get as long as the number of types of links that I have that I have in my options, in my link settings panel options. And you can probably already start seeing the problem with this code. First of all, probably the major issue with this code is the number of unused code that is running, that is actually not running, but downloading to the client whenever I download this button component, because the user can obviously choose only one link, and all the other links are not going to, all the code that renders those other links, link types are not going to run. So I have here a lot of unused code that is downloaded to the client, which obviously is one of the major performance issues that we see in websites, is a lot of unused code download to the client. So we have that here, and a lot of it. The second issue is that we are downloading to the client large data structures. So we also downloading all the pages and also the entire structures of the component that some of it maybe we don't need for to render, right? We are actually using those page ID and type, but we're ending up with rendering only an href. So this is probably a small use case, but in other use cases, we're downloading a lot of data structures to the client. A third issue here is the component logic is downloaded and run in the client. And we have many components and we have many features for each component. So we are downloading a lot of code to calculate based on the structure what actually needs to be rendered. For example, in this example, it could be the resolve link logic, even though we are running in this example just this code, but in other examples, we're running a lot of JavaScript code, and especially in low-end devices, this could be an issue. Just running JavaScript slows down the browser. And I can, if I look at high level, the issue here, and another issue here is that we're actually here rendering only one type of JS6, and the other part, for example, this button, if I have a link, doesn't execute. And like I said, it's unused code, but also unused React components that I'm just that I'm actually not rendering and not using in this case. So the high level issue here is that, first of all, my model, the structure that I have here is very different from what I ending up rendering. I'm sending a page ID and a type, but I'm rendering an href, and I need all this code and this logic to download and run it in order to calculate it. So this is the first problem. And the second problem is because I have all those customizations that I have to do the component, I'm downloading a lot of unused code to support all those different options to the user. So what I actually want to do, first of all, I want to download to and run only the code that I actually needs to actually run. And also I want to download objects that are more similar to what I'm ending up rendering. So for example, in the button use case, I actually want to download or actually pass the href to the button and not do all those calculations in the client. So let's go to the see how I fixed it in this example. Before I show you the fix, there is one question that I get a lot when I talk about this. Why not changing the structure of the document? Why not saving the href on the document when I'm publishing the site in the editor side, right? I can't just, whenever the user chooses that he wants the button link, I can calculate the href and save this instead of whatever I saved before. This could save me all this work, but it's actually, I actually moved the issue to the editor, because now the structure that I just showed you is actually an editor structure. It represents what I'm seeing right now. I have a button component here, and when I open the options, I see all those types and I can choose a different type. So it doesn't make sense to change the editor structure, because it represents exactly what I'm showing here. So I kind of want to have an editor structure, but also a viewer structure, but I don't want to save both of them in the database, because then I'm going to have issues syncing between them and all of that. So what I do want to do is I want to leave the editor model as it is, and it's going to be used in the editor for displaying this. And I want to transform it to a view model, but I want to do it in the server side and not in the client. So let's see how I did it. I'm going to go to this and let's see what's going on here. So first of all, this is after my fix. First of all, you can see in the client side, still in the renderer, I splitted the big button component into two small React components, the link button and also the regular button. As you can see, the link button is very small. It's just basically rendering an anchor, and it gets the href in the props. And the regular button just renders the label as it was before. And now I'm putting those link and regular button in my viewer components as my new type of components. The viewer does not know, the renderer does not know what button is anymore. From his perspective, there is only a link button and a regular button. And now I'm also dynamically loading them based on a new structure that I'm going to send to the client. Let's see now the server code. So I have here a new function. I called it GetComponentProps. And what I'm going to do, basically the only change I'm going to do in my index file, instead of fetching the site structure, now I'll get the GetComponentProps, which is again a server function. I'll probably do it in something that we call a front-end server, which is written in Node, and it basically communicates with the backend, with the real backend, either the database or the APIs. But it's a front-end server. It's written in Node, and it's written actually by front-end developers. We developed this entire infrastructure behind it, and we use it a lot lately. So this is an example of it. I'll go back to the server code. The GetComponentProps, as you can see, it basically returns. Let's start from the end. It basically returns the props of my viewer, okay, of my render. Let's see how I build it. So I'm using the site structure. Before I got it in the client side. Now I'm getting it in my front-end server. I'm looping the components. The first thing that I want to do is I want to change the type of the component, because the type of the component is probably, in some cases, it's not going to be the type of the component that I want to download in my render in the view side. So I have here something that I call a comp type resolver, which in my case is basically a function that gets a comp data, and now it returns a new type based on the comp data, based on the link object of the comp data. So it could either be a link button or a regular button. And the second thing that I want to do in this function is actually, now that I have a new type, I want to run the comp props resolver. So now it's based on the new type that I created in the comp type resolver. So a regular button will simply have a label, and my new link button props resolver will actually calculate both the href and the label. And now all the logic that I had in the client side is now moved to the server side. So it's the same code exactly. It gets data and it returns a data. So everything here can run in the server side. So let's go back and let's give a small overview for what we saw. So the major benefits of moving the code to the server side, returning new types of components and developing those small components. So I moved all the link resolving to the server and passed only href to the client. Like I said, I moved all the logic. I don't need to download it to the client. As I said, downloading a lot of JavaScript is probably the most painful or the least performant way that you can write web applications. You want to download as less as possible. And also you want to run as less as possible. So I'm only also running less in the client, moving all the logic to the server. I removed all the large data items from the structure. Now I don't need to download all the pages, and I need to download much less of the structure of the components because I'm downloading only what I need per every use case. I rewrote and split the button component. Instead of having this huge one button component that had all the use cases, now I have small components which are easier to write and also easier to maintain. They don't have any barely logic inside them. Like I said, I'm also dynamically downloading only the component that I need to run and to render. And also what I'm doing, because it's a server function and I can cache the response and we're actually caching the response in CDN for faster response. And we're using the URL as the cache key. So in our case, we'll put the ID of the JSON inside this URL that we're sending to the server, and we're caching the results. So now we don't even, in most cases, we don't even calculate all this object. It's cached unless the user changed his site, published his site, and then the ID changes, and then we're running it again. So, and now we're not even running this logic at all when the user visits our site. So you can imagine how much code, first of all, we saved from downloading the client and also running at all. So our client, our web application in the client got much leaner. It doesn't have as much JavaScript. Again, this button link is a small example, but you can imagine how many components we have. We have hundreds of components. Each one of them has many features, and all of them used to be downloaded to the client. A lot of unused code and a lot of code just in general, even if it was used, it was a lot of code. So, and we just moved everything to the server, cached it, and now it doesn't even run when a user visits Wix websites, which made a huge difference in our performance. I want to talk a little bit about that trade-offs that we're still researching and some stuff that we saw along the way. Like I said, we're caching server response. So now we're dealing with invalidations, because when the user changes something in his website, we need to invalidate the cache. But actually, we're not only using the structure of the site in the server, we're using other models. And then we need to think about invalidations when those model changes. So I'll give you an example of something a little bit more complicated. Imagine that you're developing a product page and you're deciding to put the price of the product in the server side. Now you need to invalidate the result if the product price changes. Now, if it changes too much, product price could change every day. Maybe you wanted to rethink if you want to put it in the server side. Maybe it's better to put it in the client side. And we have those, and we see, and we also monitor how much time, how frequently we invalidate the cache. And if we see that we invalidate too much and we see that some data that is causing the invalidations, maybe we should put it in the client side instead. So this is kind of like the trade-offs between putting stuff in the server and caching them and putting stuff in the client side. Another trade-off that we saw is when to split components. Like you saw, we took the button component, the big button component, and we split it into two small components. But in some use cases, if you split too much, you're ending up with a lot of small components. So if there's a website with many components, now you're having, maybe you're downloading less JavaScript, but now you have a lot of small files. And the issue with small files is that small files, it's not very good for compression. So gzip works much better for large size files because it uses functions, and it matches patterns of strings inside this file. And if you have small files, as the bigger the file, the better the compression. So, and also you're paying the penalty for any network request that you're doing, right? You have an extra, I wouldn't call it penalty, but just overhead of network requests. You want to do as less as possible. So splitting too much might cause problems. You're going to have too many network requests. Now, to solve it, what we thought is, first of all, the naive approach is basically to write a service that we actually researched it, write a service that concatenates all the files in runtime. So it could be like a server that gets files, basically just concatenates them, send it to the client, and also cache the result. But then you're going to have issues with common code between those, because obviously you're going to have common code that you're downloading twice. And also you're going to pay the result of the concatenation. So we're still researching if this is the right way to go. We actually researched building components in runtime. So there's this new web build tool called ESBuild that we researched, and ESBuild is very fast compared to the other build tools. So you can use it in runtime to build your components. So again, you can create a service that gets all those list of components, build them in runtime, and then cache and send the response. But ESBuild is too immature to use, so we're basically still in the research phase. And another thing that we thought to do is actually you want to group files that are commonly used in sites. This is something that we also I've researched recently. What you want to do, if let's say image and text, those components are commonly used, let's say in 80% of the sites, you probably want to group them together. You can do this in build time. You can send BI, you can measure how many components are in every website, and you can see the combinations. You want to group by combinations. And then if, for example, for 80% of the sites, two components come together, you want to group them together and then save those small files, just get a bigger file. It's probably going to have better compression. And also, obviously, you're paying the price for the other 20% because those other 20% are getting more than they need. But, it's a numbers game. So we're actually researching this, but we did find that it's an issue for some sites with a lot of network requests, because sometimes we just split a lot. This is it about the components part. If you have any questions about this part, then go ahead. You can also ask in the end. If not, I'll go to the next part. Cool. So the next part, so I talked about the components. Okay, I see that I do have a question. Not a question. Yes, a question. So let's read by Max. I see how this works for completely static content, but what if there is some degree of interactivity where JS is needed? Or do you not have to deal with that at all? So we are downloading JavaScript to the client. Like I said, we are downloading the link component and the button component to the client side, each one whenever it's used. So for example, if I need to, so I do have client side hydration and interactivity. I download it only when it's used. So for example, if the user chose to open a lightbox, I do download this lightbox button, and it will handle the interactivity on the client side. So we do have interactions, and we are downloading JavaScript to the client side. It's not that we're not downloading at all, but we are downloading only what's needed. Another question. Also, is there any rehydration happening? Yeah. So like I said, we are hydrating. It's not static sites. It's fully interactive sites, and we are downloading all those JavaScript that we do need to the client side. Cool. Oops. Okay, so I want to say one more thing about the components. I talked about this button component, and I talked about how I split the button component. If I see that I'm rendering different things based on some customizations that the user chose, I'm giving the user the option to change the component, and then I actually want to render two different things. But sometimes this is not that simple, and I want to give you an example. So again, I'll go back to this now, to the issue that I showed you before. So here again, I see that sometimes I'm returning this React component, sometimes I'm returning this. But in a lot of cases, especially for big components, I can write a big component, and only inside the component, I have some stuff that I want to conditionally download. I have an example for this in this product page. Let's look at this example of a product page. So a product page might look like this. It has a title, it has a description, it has an image. This has those tags, those elements are downloaded and rendered for all the product pages. But then I have some optional elements that I want to give the ability for the user to choose if he wants them or not. So for example, comments or reviews or suggested items could be optional. And obviously I want to download only those that are actually rendered. If the user didn't choose any of them, I want to display and download only this code. I don't want the user to pay the price. I want to be able to add more features without hurting users that never uses those features. So obviously with this, if I run my code like this, I'm always bundling comments, reviews, and suggested items into my product page. And this is could be problematic. And it was an issue in our big components. Now, you're probably already aware of dynamic loading using React Lazy. React Lazy is the way that React is actually recommending to code split and dynamically load React components. So it looks something like this. Instead of statically importing those components, I basically just dynamically import them inside the component, comments, reviews, suggested items, and they will be downloaded if the code, if the React component actually rendered them, if the product page actually rendered them. Now, I didn't talk about this at the beginning, but we are using server-side rendering. And React Lazy does not work with server-side rendering because first of all, the thing is with React is that the hydrate, when you're doing hydrate in the client side, it has to match the response that you got from the server. And the way React Lazy works is that it sends the request to get the inner React component that it's doing with React Lazy only after the first render. So what you're going to get if you're using React Lazy and you're using server-side rendering is that you're displaying the content of the HTML after the first render, but then you're rendering any one of those components, and then you're fetching the components. You actually need to get the code of the comments or of the component. And then what React Lazy will do, it will display a spinner or something like that. So whatever you rendered in the server-side rendering, now you have to display a spinner or something like that. You cannot default for whatever was returned in server-side rendering. React will not let you do that. So React Lazy does not work for server-side rendering. And what we found out that does work for server-side rendering is a library called loadable components that we started using very recently. So loadable components is very similar to React Lazy. You see the API is very similar. Instead of using React Lazy, I use loadable, and this function is you get it from the library, the loadable components. It gets the function exactly like React Lazy, the dynamic import. And the way that it works is that it renders your someone needs to mute. So it renders your component in SSR, but what it also does in SSR is actually marking in server side, in the server, that this component needs to be downloaded in the client. And then the library has an API that you can use to get all the scripts that needed to be downloaded in the client, so you can stream it in your HTML. After you render in SSR, you call their API to get the script tags, you stream it to the HTML, and now in the client side, you can also, they have an API to wait for those scripts to be downloaded, because what you want to wait for those components to download before you render, before the first render, because after the first render, you cannot do any more fetching of components. You need all the components in the first render. So it has an API also to get all the script tags in the server, and also to wait for them in the client. And then only after they are downloaded, you can render the product page, and all those components in the first render are going to be there. So this is a super cool library that we recently been started using, and it dramatically improves the performance for those big components. So sometimes splitting those components into smaller ones is only for when you're rendering completely different HTML or JS6 in this case. But for cases like those, like the product page, loadable components solve this use case for us. Okay, so cool. Let's go to the other part. I want to talk to you about. Okay, we have some time, and I want to leave questions for the end, so I'll try to do it quick. But again, if you have any questions, please stop me and ask, or write in the chat. This other use case that I want to talk about are not for we talked about components, but now I want to talk about general features in our application that are not very related, are related to components, but we don't write them as React components. And I want to give an example in the Wix Editor. So let's take this feature. It's called Velo, and it gives the ability for users to add user code, actually JavaScript code that you can write on your Wix websites to actually add any ability to your Wix website. So writing in kind of like jQuery-like API, you can select elements and change them. You can go fetch data, and you can insert them to components. And you do that by just turning on the dev mode and start writing code here. So I'm not going to dive into this feature and how it works. Actually, I did a meetup, I think it was around a year ago, where I talked about how we developed this feature. So if you want to see if it sounds interesting to you, you can go check it out at the Wix Engineering, probably in the YouTube channel. But today I want to talk about just how this feature is structured in our application. So let's imagine how we could write at least the beginning of this feature in our code. So first of all, what I probably want to do is the most important thing for me with this feature is I want to run it before I render, because the thing with this feature is it can change other components, and I want to run it before the render. I don't want the site to be rendered only then to run this code. So I probably want to run it before the render. I also want to run it, download it only if it exists in the site. We talked about this before with components, and we're doing the same things with features. So for example, we'll write something like if user code on site, then I probably want to dynamically import it. And also what I probably want to do is I want to, I probably want to call some asynchronous function, which will probably do some asynchronous stuff here before the render. But another feature that I want to talk about is actually a feature that enables users to log into Wix websites. It's not related to specifically to user code, but you'll see how it's connected in a second. So I'm gonna add a login bar here. And now I have the ability for users to log into my website. But the connection between those features is that, so those are two separate features. I can have one without the other, but I can use the API of the site members in my user code. So if I can import Wix users here, and I can call Wix users on login, and I can write a handler when the user logs in. So let's do the same thing here for site members. And same thing for site members, right? I need to initialize it. I need to dynamically download it on site. If it's on site, I want to dynamically import it and also do the initiation where they probably get the cookie sent to the server and authorize the user and all of that. But now I want to, as I said, I want the user on site to use the site members, right? So it's probably gonna have some API, and I want to send the API to the user code. So it will probably look something like this. After everything, it would probably look something like this or something like this. So if I have site members on site, I'm going to dynamically import it. I'm going to create some API, and I'm going to initiate it, again, asynchronously. And same thing for user code. And you can probably imagine that I can have more features here. And obviously, like I said, I want to pass site members API to the user code so you can use the API. So let's go over the issues here. So first of all, one of the critical issues that I have here is waterfall of dynamic imports and also the initiation phase. So all my async phases here are just in one big waterfall and one after the other, not parallelizing at all here. Another big issue here is when adding a new feature, I need to add it in this code in the right place, because of the dependencies between those features. The orders of the initialization matters here. So the developer has to know where to put the feature in the right place. If it has dependency on Wix code, it needs to be under it and stuff like that. And I think the most important thing here is that those async phases that I have here, they're not declared anywhere. They're just randomly in the application. And then it's very hard for me as someone who designed the entire application to understand where are the phases, where are the places that the application can do something asynchronously, or not even asynchronously, just something that might take more time and I want to monitor it. This way is actually a way that a lot of applications are structured, is actually not organized. You want to organize the application in a way that where the main phase is. And in high level, again, the issue is that the infra code here, which is again probably the most infra code, the deep code that we have in our application, is actually depends on implementations of features instead of abstractions. And this is something that is talked about in the OCP principles in the Solid, where they talk about like software engineering. It says that you want to have your application open for open for modification, but closed for modification, but open for extensions. And I think the best example is with this calculator, the implementation of a calculator, where you have where you want the calculator to be dependent on abstractions like operations and not on the implementations. You don't want to implement the implementation of the calculator, the implementation of the operations inside the calculator. You want the calculator to be dependent on an operations and inject the operations from outside. So the same thing with our application. So let's see how I fixed it here. So let's see what I have here. Let's go over line by line. First of all, the first thing that I want to do is I want to go to the server again and to see which feature are on the site, right? I want to do all those calculations, probably again, based on the model, which features are actually are on the site. And then I get an array of feature names. Then what I want to do is I have this map of feature loaders, right? Just a function between a name of a feature and a function that dynamically imports it. And I want to call them together in parallel. And I want to obviously it's very easy for me now to basically monitor it, right? Monitor this function to know how much time it took to get all the features in a single page. I can also monitor each one of them here. And now I want to initialize an IOC container. IOC container means that it basically handles all the initiation and dependencies between those features. So let's see an example of a feature. Let's take this small example of a feature. It has the user code factory. It has the dependencies. It declares, first of all, it declares its name. It declares its dependencies, and it declares in which phases it wants to hook into. So if it declares the init phase, now it has an init function. So this container is going to initialize all the features, in the right order based on the dependencies. And now it gives me the ability to get all, for example, I have this function get all implementers of phase, right? If I want all of the features that implement the init phase, now I'm getting all of them. And now I can call them again, asynchronous to asynchronous function and call all of the init functions together. And again, is very easy to monitor this way, monitor the phases of your application. And again, the container, I'm not going to go over the code, but it's very basic code for initializing and handling dependencies. There are a lot of libraries like that you can use in the internet. So let's go over the benefits of this code versus the other implementation. First of all, adding new feature does not require changing infra code. Like we talked about the open close principle, that this code is not going to be touched at all, right? And you can extend the features basically by adding another feature loader here. And also, I didn't show it in the user code, but you have the ability to export the function that is going to run on the server side. When are you downloading, right? Maybe in the user code example, we'll have this user code running Boolean that's going to tell us when to download this feature. And also you have the ability to get the data. We don't want to send the entire model to the client side. We want each feature to tell us which part of the data it needs, and then we'll inject the data in the features data to the factory of the feature. So like I said, developer doesn't need to worry about the whole initiation phase. The modules are singletons, which could be very beneficial for when developing, when saving state and all of that. They could be much less complex to develop features. Like I said, only modules and data that run are actually downloaded and initiated, and lifecycles are well defined and makes the application organized and easy to monitor, which is probably one of the most important things when you want to develop an application, a fast application. You need the ability to monitor and organize the application in a way that you understand where the the slow parts of the application. So we have 5 minutes left, and I want to have time for questions. So I'm going to skip the trade-off of this part. And I want to summarize in a few words. So I gave you here two, let's say, first of all, I presented two real issues that we had in our previous application, and also techniques, design patterns of how those could be solved. But this sounds, I hope that it wasn't sound too specific to our application. I think that both of those issues, also models that are very far from very different from how they are rendered, is actually an issue that you can find in a lot of web applications. Obviously, unused code downloaded to client is a big issue for a lot of web applications. And a lot of web applications save their data in the database based on queries that they want to download, that they want to query on the database, but not how they want to render them. So then they have to download all this data and calculate how they ended up rendering them. So this is why you have to download a lot of code to do it. So this is one issue, and the issue about the features. Any application, it's probably not an issue for small applications, but definitely for medium or large applications, you're gonna have a lot of logic all over your application, and if it's not organized, you're gonna have performance issues. It's gonna be very hard for you to monitor and understand what's going on your application. And obviously, simplicity, I guess it's the number one rule for creating performant applications. So I think that if you're having a medium or a large application, this might be a good idea to do. Even if you have a small one, then you can start with it. If you know that it's going to grow, you can start by doing something like that. And then, because it's much harder to do the rewrite after that, to this kind of approach. So I guess that's it for me. If you have any questions, I'm gonna stay here also. Thank you very much for joining. I hope it was interesting for you.